Hello everyone. Today we're going to be solving another leetcode problem, and this problem is 700 search in a binary search tree. Okay, so let's get started. The problem says, you're given the root of a binary search tree, BST, and an integer val. Find the node in the binary search tree that the node's value equals val and return the subtree routed with that node. If such a node doesn't exist, return null. Okay, so let's get started. Here we're seeing our first example, and we have the val, which is 2. So we're going to be looking, and here in first site, we found 2, and so we have to return all the 3. In this case, is 2, 1, 3. That's what we are going to be returning. So let's look at the other example, which is root, and here we can see all the 3. And the value is 5. And at first sign, we do not find that number, so we return anything. So we return no. So let's get in the example here. We have 4, 2, 7, and then we have 1 and 3. And the result that we're going to be returning is 2, 1, and 3. And before we continue with the solution of this problem, I would like that we remember the binary tree traversals, which are pre-order, in order, and plus order, right? So if the pre-order, remember that we're going to start with a node. Later, we're going to move on to the left and then to the right. In the in order, we're going to start from the left. Later, we're moving to the node. And finally, we're going to the right. In the plus order, we're going to start with the left. Then we're moving to the right. And then we're moving to the node. Right? So if we do the traversals here in the pre-order, what will be the result? Okay, so we're going to start from the node, which is 4. Later, we move on to the left, which is 2. Later, we move on to 1. And later, we move on to 3. And finally, we move on to 7. Because we're going to node, left, then we go again to the node, then left, then right, and at the end we move to the right. So if we look carefully, we do not need to do the other traversals, because here we're seeing that, wait a second, we're having the result, right? Because we're having 2, 1, and 3, and here I'm having 2, 1, and 3. So this is the subtree that actually we must return. So what do you think if we solve this problem by using the pre-order traversal? So with that example, let's start with the pre-order traversal. So I'm going to be defining a stack. And here in my stack, I'm going to be defining my root. And here I'm going to start with a while loop. While a stack, it means while we're having all those elements, let's start with the pre-order traversal. So let's not add logic, just let's start thinking about the pre-order traversal in code. So while we're having this stack, what will be the thing that we're going to do? We have a current pointer, and that current pointer will be equal to stack.pop. Once we're having that, we want to continue traversing all the tree. So if current dot right, because remember that we're using a stack, the first thing that we wanted to go away in this case will be the left side. So remember that we're going to be pushing from right later to left. So if current dot right exists, then we're going to be adding that. So it's stack.pop, right? No, sorry, it's stack.append, because we'll be appending that value. And in this case, it's current.right. And if the element exists, let's say in this case, sorry, just hold on a second. Okay, so if current.left exists, then I want to add extract.append, right? So I'm gonna be putting current.left. Okay, so we're having all those elements. Okay, so we have already done the pre-order traversal. This is it, but we're gonna be having the value here, which is val. So if we're gonna be traversing all this, we want to return all the subtree. So let's imagine, in this case, if current.val it's equal to val, what we want to return? We want to return actually current, because the thing that we're gonna be returning, it's gonna be actually all of this, right? Because if this is current, we want to return all the elements that come besides that element, which this case is 1 and actually 3, right? So that's the thing that we wanted to do right now. So we're going to be returning true, and if we don't find an element, so when our while loop stops, what we're going to be returning. So we're going to return, in this case, no. We're going to be returning anything. So let's stop and run the code. And it is accepted. So here comes my favorite part, which is seeing if it is accepted. Okay, we're having a trouble. Okay, null is not defined. So we're going to be returning none. Because if we're going to be returning none, then we're going to be returning anything. So it works. So we have already made our exercise with flying colors. So that was everything for the explanation for today, and I hope that you understood the video. See you later.